Good afternoon and welcome to webinar number 6 in our Wisconsin Citizen Lake Monitoring Network Spring Webinar Series. This is Paul Skowinski. I'm the statewide educator for the network. Last week's webinar was originally scheduled to be the last one in the spring series, but we have had great responses to the webinars so far, and we decided to add 2 additional webinars today and next week. A couple of the usual reminders again. All of you that have been with us for other webinars have heard these before, but all webinars will be recorded and we'll be posting them to the Extension Lakes YouTube channel, typically within a day. And please use the chat function in Zoom to ask any of your questions today. In addition to that, please keep yourself muted and turn off webcams during the presentation. I can turn off webcams if I see other people sharing webcams as we go. I'll turn those off just to keep bandwidth issues to a minimum and keep the webinar running as smoothly as we can today. We do have one more webinar coming up next week. Sorry, that should say Wednesday, May 20th at 12 o'clock on lake ice and lake ice research with Dr. John Magnuson, who's a retired professor of limnology and the former director of the Center for Limnology at UW-Madison. So hopefully you can join us again for that webinar next week. Now today is talking all about karst landscapes and implications for water quality monitoring. We have Forrest Jahnke here from the Crawford Stewardship Project and 2 of his colleagues as well. So it'll be sort of a 3-part presentation today, and they plan on taking questions after each section of the presentation. So Forrest, you can go ahead and start sharing your screen and take it away.
All right, thank you much. Hopefully our audio's coming in all right. You were breaking up just a little bit there, Paul. And yeah, I'd like to reiterate, if everyone can please just keep themselves on mute and not bother sharing your screen video. That'll help us keep this flowing as well as possible. Hopefully I'm coming through all right and everyone can see these slides. I want to thank the Citizen Lake Monitoring Network for inviting us to give this presentation on karst landscapes and our water quality monitoring program here in Southwest Wisconsin with Crawford Stewardship Project. Also want to thank the Water Action Volunteers Program and with the DNR and UW Stevens Point for working with us and helping us share all this information that we've been gathering. So as was mentioned, we work for Crawford Stewardship Project, and the 3 main pillars of our mission are environmental justice, local control of natural resources, and sustainable land and water use. I've grown up in this area and grew up drinking water from our local springs, and more recently have had the opportunity to really study the complexities of our local karst hydrogeology with the University of Illinois, Chicago Professor Emeritus Kelvin Rodolph. Invaluable in our karst landscapes and groundwater susceptibility survey, and I've acted as his apprentice in that. I've learned a lot, and I'm always happy to share as much information on this as I can with everyone. Also with us here today are our Crawford Stewardship Project Water Quality Monitoring Program Coordinator Omaru Eras and our Community Engagement Coordinator Eli Mandel. They'll introduce themselves a little bit more in the next parts of our presentation as they take you through some other parts of this. So first we'll be starting off with the basics of karst geology before we move on to how that impacts our water quality monitoring program, and then some of the wider connections with land use and values around that. So the very basics of karst is that it is an ancient carbonate bedrock carbonate bedrocks are slowly dissolved by the carbonic acid in water, and as the rain percolates through it, it is dissolved, forming, as you can see here, both horizontal and vertical fractures, which over time can go into some of these larger solution features you see here, such as caves, underground rivers, and then later emerge out into the surface as our lovely cold streams we have here that are great for trout and many other aquatic ecosystems. So we know enough from the studies to know that it's extremely complicated. We know enough to know that it's very susceptible to pollution. However, we hope that there is much more study of the specifics of these features, particularly here in Southwest Wisconsin. And there's much more study of these, and we think that's very important, as you'll see as we continue going through these and seeing the susceptibilities to groundwater pollution caused by this kind of landscape and hydrogeology. So very basics, some of the karst features we see on the left here is a picture of a quarry face. Quarries are great local cross sections of your bedrock, and you can see there those same vertical and horizontal fracturing that we noted in the diagrams. And right here we have labeled some of those surface features of, as well as underground features of karst geology, blind valleys, sinkholes, stream sinks. Underground we have our fractures, caves, underground rivers, and then where it goes back to the surface through a spring. So going through a little bit more in depth on some of these surface features, please feel free at any point to write in questions into the chat box as we go through. We're going to be going through a lot of information here fairly quickly, so if there's anything to clarify, please feel free to type in your questions, and we'll have a couple points where we'll be able to get to those. So here you see a very large sinkhole that could easily swallow a school bus. Some of these sinkholes are much smaller. Some of them are very actively changing and transforming year from year. The younger ones, newly collapsing. A lot of times you'll see much steeper sides on the sinkholes where they're actively developing. And others like this one are much older, more stable. Some of them are thousands of years old. Another common feature that people are familiar with in this area are caves. Those are some of the larger karst features on our landscape. And these have been used for hundreds, if not thousands of years by people in this area to store things and take shelter and age cheeses and all sorts of things. Also, it's valuable to note that we only really know of the caves that emerge to the surface, and many more caves and cave systems that are underground and are not connected to the surface that we have not studied and don't know about. So these are very important features in our underground landscape. Another very important feature that we really focus on are springs. These are the connection of groundwater to surface water. And as you can see here in these two pictures, they can take many forms. The one on the left, the groundwater is gushing straight out from the bedrock in the hillside. The one on the right is coming up through sand and churning and bubbling up through that into the stream. So these are very important features for us to be able to access the groundwater right as it comes out to the surface, where we can potentially monitor it. So a little bit on where karst is found. Short answer, all over the world. Here's a map of the US. You can see there's various kinds of karst, carbonate bedrocks that are found throughout the nation. You see here in Wisconsin, there's a belt going through eastern, southern, and western Wisconsin, where we have carbonate bedrock. About a third of our state has some amount of carbonate bedrock underlying it. Zooming in a little more to Wisconsin now, you'll see those layers of carbonate bedrock. There's actually 3 distinct layers of carbonate bedrock in Wisconsin. In eastern Wisconsin, the youngest layer of carbonate bedrock is the Silurian dolomite, and those 15 Wisconsin have in the last year or two come under some additional regulations from the DNR to deal with the groundwater, drinking water issues that they've been seeing there, and that they've found through the extensive well testing that they've done out there. And it's been some pretty good geological studies done of the depth to bedrock and where various karst features are, different areas that are more susceptible to groundwater. And we're really hoping those studies can be extended into some of these other layers. You'll see the emerald green layer that goes through eastern and southern Wisconsin mostly. That's the Sinope group, which is the Platteville Galena limestone, a very soluble and often close to the surface layer of bedrock. And then finally, the oldest layer, the deepest layer of carbonate that we have here is the light blue, and that's the Prairie du Chien dolomite. And that's the main carbonate bedrock layer that we work with here in southwestern Wisconsin and western Wisconsin. And as we go through the older and older bedrocks, they have had more time to go through those processes of dissolution and, generally speaking, have larger fracture patterns, bigger caves, underground rivers, and things like that. So we can expect older bedrock to be more dissolved over the years. Also like to bring your attention to the bottom left-hand corner where it has a cross-section of southern Wisconsin. And there you can see the different layers and the slope of the underground bedrock as well. And if you see in western Wisconsin, our bedrock is very slightly sloped to the south and west. And that has implications for potential underground water flows as well. Zooming in a little bit more into southwestern Wisconsin, centered around Crawford County, which is our base of operations here. A little bit better view of those bedrock layers that we discussed. You can see we have just a little bit of that Platteville Galena limestone on the very highest points in Crawford County. There's a lot of that in Grant, Lafayette, Iowa counties on the surface. In between the Platteville Galena limestone and the Prairie du Chien dolomite, which are our 2 carbonate layers, we have a layer of sandstone, and that's the St. Peter sandstone. And underlying all those layers in the green there is the Jordan sandstone. And that sandstone is what most people in our area are drinking out of, either through private or municipal wells. The Jordan sandstone is some of the most prolific bedrock for aquifers. It has very well-rounded sandstone particles that hold lots of water. And so far, many people in the area are still drinking very good water. We hope to keep it that way, although we know from the limited studies that have been done that there are several areas in this county and surrounding counties where they're already starting to struggle with serious ground issues. And as we go through, we will discuss more of those issues and how we can manage those. So this map here is one of the maps that we created through our Karst Landscapes and Groundwater Susceptibility Survey. Another map that we created here is a sinkhole map. We identified over 450 sinkholes of at least 2 feet in depth throughout Crawford County with the help of our citizen scientists and Professor Kelvin Rodolfo and some GIS experts who helped us plot this map. The base layer of the map you see there is what's called LIDAR, which is kind of aerial imagery taken with airplanes, and they did some laser imagery stacked with some computer algorithms that stripped away all the surface vegetation and give us a really great view of the surface topography of the area. And we used that to identify all the closed depressions, all the areas that go down slope 360 degrees, which in a driftless landscape like this, where we don't have natural lakes and things formed by glaciers, this whole landscape was the result of about 500 million years of erosion. So really any closed depression we see is going to be the result of underground features collapsing and causing sinkholes or human activity. So our citizen scientists use this LIDAR data and the aerial imagery to parse through those points and identify possible and probable sinkholes, which we have mapped here. We then took that data and generalized it to make a sinkhole concentration map. And we did this because we know that we are not mapping all the sinkholes in the county by any means. We also know that the best evidence for sinkholes and other complicated karst geology and karst features is sinkholes and complicated karst features. So taking those sinkholes that we had mapped, we plotted the concentration, and this gives us an idea of what areas of our county we can expect to find more caves, sinkholes, disappearing streams, springs, and other karst features. And so this is a potentially helpful map for mapping areas of particular concern. We also mapped karst fracture patterns. As I mentioned, our driftless landscape is mostly dendritically formed through the processes of 500 million years of erosion. However, a more educated eye, like that of Professor Kelvin Rodolfo, can see that there are what's called trellis patterns, as well as those dendritic patterns in the landscape. And we were able to map more dominant fracture orientations that show us likely directions that underground features such as caves and sinkholes, lines of sinkholes would be taking on the landscape. There's 2 layers of bedrock represented here with underneath the tan areas. One of them is the prairie dolomite, which we found 2 directional patterns in, and the other, the Platteville Galena limestone in the bottom left-hand corner, we found many more directional predominant patterns because it's closer to the surface, and limestone tends to be more soluble in water than the dolomite. So even though it's younger, it tends to be very fractured in our area. And this again could potentially be useful in thinking about what directions underground water could be flowing. Finally, in our citizen scientists' work with the Karst survey, we analyzed well construction reports. These well construction reports are really some of the few data points we have that go down into the bedrock and give us an idea of how deep different layers of bedrock are. So we use these to identify what we call karstic wells. And these wells were identified through a series of keywords that we had our citizen scientists looking through, such as cave or crevice or crumbled limestone, that were written down as notes in the well construction reports by the well drillers. So breaking down this graph for you a little bit, we only used well construction reports from Corpion because they were the only well driller that took scientifically usable notes. Fortunately for us, they did the vast majority of wells in our area. So after eliminating all the non-Corpion wells, we then also eliminated the wells that only went through sandstone, so the non-carbonate wells. So if we're only looking then at wells that went through at least some amount of carbonate bedrock, the yellow and green, the Packer colors there, we see that 28% of all wells drilled through any amount of carbonate bedrock have indications of karst features. So that tells us that really at any point that you puncture karst bedrock, you have a very good probability of hitting at least some sort of cave, fracture, crumbled limestone, or other very, very permeable bedrock. Another consideration, while it's not bedrock, that is very important for us to be looking at is the depth of soil to bedrock. As you can see here in Crawford County, where any of the color, either orange or red, is less than 5.5 feet to bedrock, most of our county has fairly shallow soils. So that again has implications for groundwater susceptibility because deeper soil helps to mitigate any potential pollutants that would be in water before they go down into the bedrock and hit those direct conduits to our groundwater. Finally, slope is very important for us, particularly here. As you can see, Crawford County is some of the steepest slopes in the state, in the region really. Very rugged topography. As you see here, black is flat, and the lighter the color, the steeper the slopes. So we're dealing with both very complicated underground hydrogeology as well as steep surface topography. And so all of that significant impacts for land use, water flows, and our water quality monitoring. So at this point, I'll take a pause and see if there's been any questions coming up in the chat that we can address now.
It looks like there was one that was answered by your following slide, but there's one left from Dave asking, at some time way in the future, will all the limestone and dolomite layers dissolve and the whole area will sink a few feet or more?
I would say that in a extremely distant future, yes, all of this will dissolve. If you want to look at some areas where karst landscapes have developed longer than they have here. There's areas in Madagascar and some areas in China and Thailand where they have very dramatic karst landscapes, giant karst towers, massive caves. And so it's not that these entire layers will disappear. They dissolve at different rates, and that gives us lots of interesting landforms like caves and karst towers and cliffs and things like that. So it's more that we're going to see a more and more complicated landscape with larger caves, deeper cracks and crevices, and faster flow of water through those layers of bedrock. I would say that in any sort of time frame that we would have to worry about, we don't have to worry about all the limestone and dolomite disappearing altogether.
Great. That was the only question in the chat at this point.
Okay, great. So thanks for the questions. Again, we're here to answer whatever, and just type in your questions as we go. Oh, there we go. So now connect this information that we've learned about our hydrogeology with water quality monitoring. Our water quality monitoring program coordinator, Omaru Eras, is feeling a little ill today, so I'll be taking you through this part, but she'll be available for questions and answers at the end. So we've been doing water quality monitoring in this area for over a decade now. It's a citizen science-based program. We've been working through the Department of Natural Resources Water Action Volunteers program. We do their basic protocols as well as some more that we'll go into a little bit further in the presentation. We work with various labs, other nonprofit partners, as well as our 10 plus very dedicated water quality monitoring volunteers that go out on the landscape and help us do this monitoring. So here we've zoomed in a little bit more on some of that LiDAR elevation data, which gives us that great view of the surface topography. And you can see how we've used this to select our water quality monitoring sites, which are the orange dots labeled 1, 2, 3. In the dark red and lighter red, you have watershed boundaries. And so this helps us see where the water, what direction the water is going to flow from that point. And as you can see, we've chosen our water quality monitoring sites at the outlets of some of these sub-watersheds into the Kickapoo River Valley. So this is a picture of the lower Kickapoo River right before it drains into the Wisconsin River. And you can see some of those sinkholes that we identified as well that are the green points. This area we chose specifically because we focus on areas of particular concern. This area is under a proposal for potentially spreading 6 million gallons of liquid manure in the future. So we wanted to get baseline data before that started happening. So this is some of the more recent sites that we've added to our program. We started that just this last year, and partially due to the extreme rainfall events we've been getting, as well as some already existing less than ideal land uses, we've been seeing some pretty alarming results in these streams already, even though these are fairly small, some of them relatively intermittent streams. So they're fed by both surface and groundwater at different points. And point number 3, which is just outside these areas, is a spring, and that we're hoping gives us a bit of a baseline of what pure groundwater looks like coming out, as opposed to the groundwater fed and surface water fed streams that we're monitoring at points 1 and 2. So now moving on to a little bit more of the specifics of how we run our program. Like I said, we follow the basic wave parameters of dissolved oxygen and temperature and pH and stream flow, but we also really focus on some other criteria that we see as just as important, if not more important, those being E. coli and background bacteria, total phosphorus, and fungi, as well as some source track testing for some of those bacterial results to identify what species those bacteria are coming from. E. coli is very important, and there are actually standards around that. So we see that as a very critical parameter to monitor. The total phosphorus is also very important for the quality of our stream, since that's the limiting nutrient for algae blooms and a lot of the effects we see lower in the watershed. And background bacteria, we really like to keep tabs on. We've been finding some extremely high results in that, and that's a very broad category of a lot of different bacteria, some of which are even more dangerous than E. coli, such as Salmonella, Cryptosporidium, and Staphylococcus aureus. We've also, speaking of staph, found some antibiotic-resistant bacteria in our streams. We also test for that. We found bacteria resistant to chloramphenicol, which is not supposed to be used anymore. And we also have heard of people getting MRSA, which is methicillin-resistant Staphylococcus aureus, in the lower Wisconsin River. So we know that there's some pretty extremely dangerous things in these rivers. As you'll see, our volunteers are wearing masks and gloves. This is before COVID-19. We were taking these precautions because there are lots of dangerous probes in these streams, and we want to keep our volunteers safe and protected. So some of the challenges we deal with on this complicated landscape in water quality monitoring include some long walks to access the sites, sometimes through muddy, complicated terrain. Sometimes there's lots of poisonous plants, poison ivy, parsnips, stinging nettles, things that we have to inform our volunteers about. Also, we've been seeing some pretty dramatic changes in a lot of the streams we've been monitoring. After all flood events, it totally changes the profile of the streams significantly, which sometimes makes us change the point we have to monitor. Also, we have to consider different points of access. Sometimes we have access to the property with permission from the landowner. Sometimes we don't and have to monitor from a bridge, as you see in the upper picture here. We have poles for doing some of this bridge monitoring, so we can access the stream without having to go down to it. This, of course, does not allow us to do the full range of parameters, but we can still take tests for E. coli and phosphorus and such. In the lower picture here, you'll see that stream is extremely shallow. That's actually a spring that comes right out from the hill there. It's less than an inch deep for most of it. So for that, we've actually been using a special syringe to suck up the water, fill up our sample bottles. And so those are some of the challenges that we've been dealing with and some of the ways we've found to work around these issues and monitor streams that are outside of the basic parameters of wave, which we found are really focused on larger rivers and larger bodies of water. And here we're dealing with lots of little streams and creeks. So some of the other safety protocols that we take, of course, are alcohol and bleach. And we make sure that our monitors are not spreading invasive species and are not getting themselves sick through contaminated equipment and boots and such. So now just briefly, if we can go into some of the results we've been finding, so you can have some idea of what we're talking about. This is a graph of our E. coli results around what we call zone 2, which is an area that drains directly into the Wisconsin River. We have 3 different sites that we've been monitoring there, 2 of them for about a decade. We chose this site because it's in the area of an existing concentrated animal feeding operation that's spreading large amounts of liquid hog manure in that area that we're concerned about. And as you can see here, our results have never been great from the beginning. If you see, the standard here is 126 colony forming units per 100 milliliters. In the first few years, it was sometimes below, sometimes over, with a few spikes. And then in the last handful of years, it's been, well, almost never below the standard and has had very extreme spikes of E. coli. Partially because of these spikes, and to show this data, we've actually had to refine and change the parameters of our graph. So you see this graph goes up to 5,000. We then changed it to go up to 170,000, which matches our highest result that we got last year. And here you can see again that the results and these spikes have become more common through the years, and we've been seeing more and more extreme results. And phosphorus, you see a similar pattern, never great results, but seemingly increasingly bad results through the years. A lot of spikes that are 40, 50 times the standard of phosphorus. And so these are, again, standard is on the bottom here of 0.057 or 0.075 milligrams per liter of phosphorus. And we see spikes considerably above that. And the purple site at the bottom, at the end here that we started monitoring more recently, is a spring. So even the spring water that we're seeing coming directly from the groundwater is already intermittently above the standard in phosphorus. And so that's very concerning when we see those kinds of nutrients, not just from surface water runoff, but actually coming directly out of the groundwater. And you can see of the same things happening in our E. coli results, where even the spring is well above the standard at times. So, do we have any questions? Now I'll go to the chat box and see if we have any questions on this. I see a few.
Yeah, there are a bunch.
Yep. So the reason, one question, expected you would measure nitrate because of the implications for water. Was the holding time a problem? So we did monitor for nitrates for a few years. However, the nitrate cycle is extremely rapid and it goes through changes very quickly. and the kind of monitoring we do, where we only go out once a month and take one point in time, wasn't really giving us very helpful results. Also, there is really no current DNR standard for nitrates to base our results off of. So we ended up dropping that protocol because we weren't really seeing helpful data, and it was costing us money that we didn't have as a small nonprofit organization. However, if the DNR wants to do nitrate training or some continuous monitoring, we would certainly be welcome that and be open to collaborating with them on that. So where on this map 6 million gallons of manure spreading going to be planned? Going back to the map, it's along Harvest Lane, and you'll see a little road shooting south about a little more than halfway to the west of Highway 131. There's going to be there's a proposed facility for roughly 8,000 hogs for that spot, and the preliminary application has been filed for that facility recently. How many residents and wells are affected by E. coli in Station C? Station C, I'm not sure what you're referring to, but in Crawford County, we have done some well testing. So far, only one well of the 53 that we did in our last well testing program tested positive for E. coli. More have tested positive for coliforms in general. And it seems like the concern in most residential wells is nitrates, particularly when we're talking about concerns from the groundwater. Many people's issues with bacteria and E. coli in their wells are actually a result of your well system being contaminated rather than the groundwater itself. However, that said, there's bacteria in the groundwater in areas where there's either high concentrations of septic systems or lots of manure being spread. Mm-hmm. As for the likelihood of the hog operation application being approved, that is a good question for the DNR. I wish I had a good response for you on that. I don't. I would say likely. And a relationship between spikes in phosphorus and snowmelt in precipitation, absolutely. There's definitely a relation to that. Some of these major spikes we've seen have been when the water looked like chocolate milk and there was huge amounts of runoff going through. However, that said, some of the high results we found have not been during active runoff times. And so there's definitely a relationship between both the amount of precipitation and snowmelt, as well as the concentration of nutrients and pathogens already existing on soil and how many roots are holding all that down. We have another question about the nitrate standard, and that there's a drinking water standard for 10 milligrams per liter for nitrate. That is correct. But again, we're talking about drinking water, so that's the water that's going to come out of wells, not the water in our streams. So yeah, they really need to have a standard for our stream quality and what that should look like. So thank you for your questions. I think we're ready to move on to continue making some of these connections.
All right, hello everyone. My name is Eli Mandel. I am Community Engagement Coordinator for Crawford Stewardship Project. I grew up fishing and floating on the driftless area waterways, received my bachelor degrees in political science and environmental studies from UW-Madison in 2014. As Community Engagement Coordinator for Crawford Stewardship Project, I work to educate and spur our communities into action to promote sustainable land use, environmental justice, and local control of natural resources. In this last section, we will be helping you to make connections between our geology, our water quality monitoring, and the bigger picture of land use practices in our areas. This is meant to be an open discussion, so please type your questions in, and I will try to get them as they arise or at the end. So thank you. All right, so let's broaden the scope of these understandings a little bit concerning land use practices and the effects on our surface and groundwater. Here in this picture, you see a juxtaposition of two varying land use practices that are common here in driftless Wisconsin, here in Southwest Wisconsin. I'd like you to think about a little bit how these two different pictures might affect our groundwater and surface water quality. Here in driftless Wisconsin, our landscapes for interesting challenges which can compound the effects of unsustainable land use practices. All right, land use and the movement of contaminants through karst landscapes. So Forrest started you out with this diagram at the beginning of the presentation. So we're gonna go look into a little of the affecting results. So runoff and infiltration risks. So this is an idealized diagram, of course, not a real picture of driftless Wisconsin, but it is very representative. So we have very steep slopes and terrain here, as Forrest had pointed out, which result in many challenges for land use on rugged terrain. These challenges affect all of us here in driftless Wisconsin. We are a rural farming community, so farming is a huge part of our economy and way of life. And thus, those land use practices have a compounding effect on our landscapes and water quality. So as you can see, the shallow soil depth to bedrock on the slim surface of the soil profile that we have here in Southwest Wisconsin can again compound surface to groundwater movement of both rapid movement of water and contaminants in that water. Again, these karst features, which sometimes are hidden, sometimes are more visible than others, allow for this rapid movement of water from surface to groundwater, and then also from groundwater back to surface water through the cold spring-fed waters in our area. All right, so what impact on our water quality in streams and waterways? Here in driftless Wisconsin, we have a beautiful landscape, and these cold-fed watersheds and springs and streams are the backbone of our rural way of life. We have abundant and healthy aquatic ecosystems, some of the best trout fishing in the world, and abundant groundwater aquifers, which we all drink from. The interconnectedness of the surface and groundwater through karst features compounds the sensitive hydrogeology and makes for vulnerable watersheds. As was pointed out earlier, our changing climate is compounding all of these issues. Heavy precipitation events in the last couple decades have caused major landscape changes. Major flooding in both our river valleys and major erosive events forming gullies and coulees and flash flooding from the top of our ridges down into our valleys. These events are dangerous for both humans and the ecosystem and the landscape alike. These erosive forces, as we have been describing, threaten the health of. All right, let's move on to groundwater health and aquifer contamination. Looks like we have a question. Looks like we are still talking about some nitrates. So yes, I was going to get to this a little later, but this is a really good point about nitrates. And well testing is perhaps a better source of data than the surface water testing. So yes, we do not test for nitrate surface water anymore. But that being said, there are studies going on in Southwest Wisconsin right now testing drinking water from wells, and they are testing for both biological contaminants, E. coli, bacteria, viruses, and also the other big parameter is nitrates. And so as said before, the drinking water standard for nitrate 10 milligrams per liter. And that is really only based off of one studied disease. And unfortunately, new research is showing a whole host of possible diseases that are affected by high nitrates in drinking water. So yes, we at Crawford Stewardship Project have been lobbying for years for increased well testing and hydrogeological study in our area. And we are very happy with two major studies, the SWIG study in Grant Line in Iowa County, which is going to be completed this year, and the newly formed driftless area water study in Crawford, Richland, and Vernon counties, which will begin this fall. And we will be testing drinking water, which is groundwater, in those three counties. And so hopefully we'll have some better results about our health of our groundwaters. And that brings us right to groundwater health and aquifer contamination. And this is something that we unfortunately have not had much data on in the past. As I was saying, we have some tests or some studies going on right now. So that is really, this is really an exciting time that we hope to gather more data to be able to effectively understand what is actually happening both with our surface water and the water underneath our feet. And this brings us to some results that we have seen in the last couple of years. And this is surface water and groundwater being contaminated from manure spills, septic systems, nutrient runoff and infiltration, and frequent major flooding events. So this all is compounded by our sensitive karst geology. These contamination factors are a major cause of concern when we are looking at the health of our groundwater. And as I was saying, we will have more data on that in the end of 2020 and 2021. So we hope to make informed decisions based on that to help protect our surface and groundwater. All right, so that brings us to some of Crawford Stewardship Project's most important work in our communities, sustainable and diverse land use. So we live in a very diverse environment here in Driftless region in Wisconsin. The health of our rural communities is directly tied to the health of our surface and groundwater. Sustainable and diverse land use is affecting the health of our watersheds. These realities of the ever-changing landscapes and changing climate means we must adapt to best use practices to maintain the health of our ecosystems. This is why we advocate for farming and land conservation practices on our landscapes, diverse living land covers with roots, healthy roots in the to maintain soil health and stability and build soil health, which will help prevent the quick movement of nutrients from surface to groundwater. And why we advocate for diverse regenerative agricultural practices that help protect and maintain the bottom line of a healthy ecosystem, healthy soil, and clean air and water. One way to spur better land use practices is to protect the hydrogeology of our regional area. So these protections Forrest brought up earlier in eastern Wisconsin have been put in place and are being manifested as we speak. We hope and are advocating for more study and further protections for our region of Southwest Wisconsin based on our hydrogeological sensitivities. All right, looks like we might have a question. So this question is, will the DNR results of your studies in making decisions on the hog farm? Why or why not? I think I'll let Forrest jump in on this one.
Yes, so we will certainly be submitting all of the information that we have gathered to them. We will be asking them to take a serious look at this operation, considering these sorts of sensitivities, as well as asking for an environmental impact statement where they would have to really study. So yes, they will certainly look at them, and I hope they take it seriously and do further study of their own. And so we have another question on importance of soil quality and specific initiatives that we are leading or are aware of to encourage best management practices for protecting soil and water.
Yeah, so one of the big ones are at our local county level is cover cropping. So we have a really successful cover cropping program here in Crawford County. 20,000 acres last year were cover cropped. So that is maybe, it's a very good starting point, I would say, for farmers to start understanding that relationship of having more living cover, more roots in the ground, building healthier soil. Crawford Stewardship Project, obviously, we work to engage, advocate, our community. So we hold farmer forums. We had a regenerative agricultural forum last year. We had an industrial ag forum 2 years before that. So we definitely work to try to get that information out there. I will say, unfortunately, there are not enough programs, I think, right now, specifically tied to those economic incentives for farmers, for landowners to utilize. So we definitely need more of that.
Yeah, there are some watershed groups that have started. The farmer-led watershed council in our area has done some great work, both in well testing and incentivizing with some cost share, some of regenerative agricultural practices. But yes, in general, our economic system and agricultural policies are not great at really incentivizing regenerative agriculture. We've heard complaints from many rotational grazers that they've been doing everything right for years and years and have never received a penny of federal subsidies for anything, while corn and soy fields with absolutely no conservation practices continue to suck up federal tax subsidies every year. So there's a lot of work to be done on that.
Yeah, unfortunately right now it really seems the most of that work is being done in the nonprofit sector. So we have Trout Unlimited is very active in our region as well, dealing with stream setbacks, prairie strips to protect, like Forrest was saying, all the multitude of our small streams and rivers from these kind of sensitivities. So another question about best management practices with karst around the world.
So I'm in global best management practices for karst landscapes. I know that more locally, Wisconsin, if you want to look at some best management practices considering karst, you really have to look at south or eastern Wisconsin, where they have those some additional regulations, and those still really have yet to be implemented. So it's a developing field, and I think we're all learning a lot.
Very quickly, also in eastern Minnesota, in Driftless, Minnesota. They are doing amazing both local, regional studies, and the Minnesota state government are doing really great work there. So there's some seriously interesting and complete hydrogeological studies out of Minnesota. So that's another great reference. All right, looks like we are pretty much out of time. We have some references here for you. And our contact info.
Great. Thank you, Forrest and Eli, for presenting today. One more reminder that next week's webinar is on Wednesday, May 20th at noon again. If you haven't registered for that yet, I just put the link to the registration in the chat box, or you can find it in my latest email sent to CLMN volunteers on Monday night. And it is 1 o'clock, so thank you everyone for joining today, and I hope to see you again next week for the final webinar in our webinar series.
Thanks, everybody. Feel free to contact us if you have other questions.
Thanks again for presenting from home, guys.